So this one's actually going to be about Matplotlib, but the animations. I haven't actually done a Matplotlib video at all, but the animations. So I'm kind of like jumping one gun, but anyway, the animations come from it, so we'll see that now. But here's a binomial distribution. I wonder if I can make it slightly bigger there for the font. There we go. So we've got a binomial distribution there. We use NumPy and Matplotlib. NumPy is for generating an array here. That's what the NumPy part is for. And this is in a Jupyter notebook. So we generate this list of numbers from 0 to n+1, remembering that in coding n+1 means it always goes to the value of less. It's exclusive. This value here is excluded. I think you'll probably say in the range somewhere. We got a start and a stop. Here you go, excluding stop. So it starts at 0 and then goes to 20 minus 1, which is 21 minus 1, which is 20. So that's what this arrange thing does. So nothing special in particular. We could have used a range. It's fine. And then from that, we have this function here, which is this probability mass function, and this other function, this is the cumulative distribution function. So we've got these two functions that are generated from the binomial distribution, which comes from Skype. And we can kind of like print them out and see what they look like, but ultimately we're looking for these plots, and one of the plot is a stem plot, and we'll see what that is. I will scroll down to it, and the other one is a step plot. So, and the step plot is for the cumulative distribution function, and the difference being that cumulative means it keeps on adding up, so it's going to do something like this. That's what, in some way, and if it wasn't doing that, it would do some kind of smooth sigmoid type of curve, like one way or the other. We'd do that kind of thing. And the probability mass function, which is slightly different, is going to be, well, for the binomial distribution, it will be something like, this is a whole bunch of bars. I should actually draw the bars, but it'd be a whole bunch of bars, that kind of like generally look like this, and then I don't know, there might be a couple of outliers or something there. There we go. Like, you might have one tiny little bar over here at the end. So just something like that. So that's what the binomial distribution, generally speaking, looks like. And again, if it was the continuous version, the normal distribution, it would look like this. With my child's handwriting, it would look like this. So that's effectively what we're plotting for. So I'll remove those and just go back to the arrow, and we get there with the plot.show. We can do that, and here we get and this is what's called the stem plot over there. So here it is. The stem plot is the top one, and the one below will be the step plot. We've got stem and step. So stem is just a bunch of stems. We could have done a bar chart, so we could have just put bar in there. I wonder if I run it. I will actually run it now. And I'll use Python there. You can see it's sort of like firing itself up down below. This is in the Jupyter notebook, and then we'll get to the second one as well, because I'm just wondering if I could stick in bar. So there's our stem plot, and then this is our step plot just below, which is the cumulative version, and the cumulative goes from 0 to 1. It hits the 1 probability, or approaches the level of 1, as the numbers get larger and larger. And that's basically it. I could have put in a guess bar. I wonder if that will work just off the bat. I'm not sure that it will, actually, because the bar chart might need different things. But let's have a look. I'll get thrown an error message if it doesn't work. Yeah, it's through an error message. So I'll just Control Z, want that one back out. The error message will be something to do with the bar plot. Probably doesn't take this base format or something. I'll Control Z that out. Maybe I can just do a standard bar as well, but that's not part of it's not that important for the purpose of the video. There we go. We'll change that to a bar. I wonder if I can get away with putting nothing in there at all. Comment this one out, and then just run that. Maybe it'll run, maybe not. Let's have a look. No, it still doesn't run. I'll leave that. It's not important. We've got the stem plot, which is fine. You know, so I can get a bar plot working in time. So anyway, we have these two plots, and this was for the binomial distribution, and then similarly we have plots as well for, that's for the binomial distribution. Where is it? We've got ones for the normal distribution as well, in the same type of way, but this time normal distribution takes a mu and a sigma, and we still get the distribution functions. So it's the same type of thing. I'm just rerunning it, but although they already run, we see it running now. There we go. The data comes out, and this is a continuous distribution. So we've got our normal distribution there, and then we've got our cumulative normal distribution, or the cumulative distribution function, so of the normal distribution. So that's what we've got. And the interesting thing was, try to create. I was going to create an animation of that, or of it being constructed, or do a family of curves. And I thought that the best thing to do would be to create a new file basically to do that in. So if I can open it up somewhere, which is here, I'll kind of close this up a little bit. And yeah, I'll move that over there. And basically, I started off, or at least on this previous one here, I was like, I'll do an animation, and this is kind of like the standard animation. I sort of pulled it off of the web. I tried a few different ways, and it failed. I've got a name equals main. I was going to put this all into a main function, but the animated plot needs to. It uses, I think, the first value. This I is like, what it does is it draws it keeps drawing frames like an animation basically. So it needs like this value in here, which keeps on getting appended on each interval. So it needs something in there. I couldn't run this without it. And yeah, this produces a plot, and it does a plot.show, and then I was able to save it as an animation. I wonder if I've got the animation here actually. Yeah, I do. So kind of got it, that working. That was just for a standard animation. And where is on here? This is the function for updating the animation over here. It needs to have one argument that comes in here. This argument is it's an undefined type, but I think it gets fed in because it's called from here. And if you go from func animation here, where you've got the figure, so that's the figure that comes in. That's the first one. Then you've got the actual function itself, and then somewhere down below you've got intervals. But intervals, because I did this third argument can be anything that goes in, and so interval here, like it could have been a decimal, like a floating point number. But one thing is that this has to be in here. So if I tried to run the same thing without it, then it would fail. So it wouldn't be able to do the plot. So if I delete this I out of here, and then try to do a run, it's going to try to do the plot, and it will come up with some sort of error message. List index out of range. So I'd have to go back basically, close it up, and stick an I in here, and run it again. And this time it appears to be working because it's taking a bit longer to do, which is it's running through the simulation, basically creating this animation.gif. And the one thing about the animation is it goes into the folder that it's in, and there's a couple of bits. So again, it's produced the same GIF file. It goes into the folder that it's in, but I wanted to kind of make that a little bit better in terms of the code, which is, so let's just do that. In terms of the code, I did start it here, like make a class, because I couldn't put that function in just on its own because we had to call the function. So this update function, So I was like, well, if I put it into a class and do make animation, then I can get that to work, which is fine, and actually it does work. And then I thought over there, if I just get rid of it, I'll just make that a little bit better. So I created a whole new folder, and like now I've got something that fully works for animations that I'll use later on to do full animations. But here's the main function, and it doesn't do much now, which is quite nice. So, and I've got main guards down at the bottom, so the standard if name equals main pattern down below. In fact, I don't think I wonder if I call it the main guard. Um, if name equals main. Oh yeah, there you go. Main guard idiom. I prefer that. I've got some IntelliSense there, or not snippets to make it go a little bit faster. So this piece of the code gets run from the top here, and all it does is all I do is literally create this range from -50 to +50, and then I just take squares just to have an X and Y something there, and then I've created this class for making the animation, and the class just needs to take in the X variables and the Y variables, which are these two lists. So now it just needs these two lists effectively, and then it will do an animation on any like pairs of variables basically. So what's actually going to happen is it's sort of like we got our X's and Y's like there. So this is our X column here, and this is our Y column over here, and it's all like, there we go. And they're sort of like split up. So there are X's and Y's. And it goes through systematically. This is what the animation function actually does. It goes through systematically one by one, and it's sort of like does that one, does a drawing of it, then refreshes, so like does a drawing of that, then does a drawing of that, and so forth, and keeps doing the drawings. And it kind of like sequentially goes down, until it gets to the bottom and at the end of the animation. So that's basically what's happening in terms of that. Now, so the class takes in this X and Y, and then it does this plot variables, which is just basically it's setting itself up. And here I believe I could probably put in things that sort of like for the ax.plot, maybe change the coloring and formatting and stuff like that. So that's a place to muck around with it. Now the good thing about doing it in functions is that in a class and in functions that you can break it down into its component parts. And here's the update part, and nothing's really changed apart from I've had to use self dots everywhere. But that lets the and this is the thing, if I did it in functions, I'd have to pass these functions in and pass them back out and make sure I'm passing variables. So it just lends itself better to a class. So this is an example where classes are more useful. And again, we see remember the first variable of the class just refers to itself. The second variable here is this same I dummy variable that we had in our previous code, wherever it was. Oh, not that one. Whereas the animated plot here, it's the same function over here. So this def update I now becomes def update self I inside of a class. So that's basically it. And there's one extra bit, and then I've got another little function that does the actual animation, which I actually should call method for doing the animation, but actually saving the animation too. And save the file. And save the file. Or show the, or I have to go into the next line there, X that out, or show the animation, just to get the doc strings nice. Need to put one space in there, full stop. I wonder if the full stop, no, it doesn't make. No, it doesn't. Okay, fine, yeah. So that's basically what this particular method does. So doing the animation and showing the file, and what it actually does is it goes through, and I've put in a couple of if-else statements, and so we take a file name and a file path, and these ones are fed in from this do animation where we call it. Where is this do animation? That'll be up here. I've just put in, this is the actual whatever we want to call our file, and then this is the extension of the file. And what I've done is there's two if statements in there. One is if it's a GIF and the other one if it's an MP4, because you can have your different formats. And then if you've got neither of them in there, so like an else, so I don't know if you put in XXX because you didn't want either a GIF or an MP4, then it will just show the actual plot itself. And there was one extra bit, which was where to save it, the file path. And basically, if I go over here, I created this folder called assets. And hopefully, if I run it, I wonder if I hit F5, if it runs and puts it somewhere. I'm hoping that it saves it to the right path. And this uses os.abs path, which is the absolute path of this file. So presume it's running now, is it? Yeah, it's running because we've got a little crosshair. I pressed F5. Oh, hold on. Do I get an error message? No, I've got an error message from something previous. So it's running and it looks like it's done. I'm just going to go in here. Yeah, and here we go. We've got the assets and we've got the animation. And yeah, it does work. Fantastic. I didn't do that. This was all real time. So there was no pre-planning. But yeah, it seems to work. That's the animated GIF that goes into assets. Actually, this error message was from earlier, which was that this self.path thing, when it will actually come to do the path, I saw that I do this os.path.join to construct the full path name of where it's going to go, and I should actually print where it's saved. I've made this folder and I didn't actually have the folder. So one thing that I could do, or like, you should do, is check that, put in a check if the folder exists, but I don't do that. So that's basically it. I just noticed that I just put this little red bar here, this little vertical red bar down the side, because in theory Python code shouldn't overlap, shouldn't be more than 90 characters long. So I'll just move this, I guess, somewhere down to the next line like that. This is the animation itself. And that's really it. Now we've got an animation. We've got something or a method, or a class at least, where we can call it really easily. And I can modify and work on the class, but all we have to do basically is call a class and pass in a bunch of x values, which is just a range of numbers. And then I could have used NumPy again to do it. There was the NumPy range, or I just made a standard list here. And then over here there is the y values, and this was just y equals x squared, just to have something, But again, if I called it y equals like x cubed and did my animation, or I'll now call it something like x cubed. There we go, x cubed, hit F5 to run the code, and it should create a second chart in the animation, and it'll do it as a GIF. I could change it to MP4 to have a little tester of it, because I've not tested the MP4 functionality yet. I just stuck it in as if and else statements, because I just didn't want to forget they was there actually, more than anything else. I don't know if one's better than the other one for websites. And here we go, we've got x cubed now. Let's see what that looks like. And it does something slightly different. There we go. So very nice, and I'll have a little play around with it. I need to calibrate on this particular chart. I need to do calibrations for things like, or get these in line, which is like the number of steps. At the moment, this is a default interval anyway, which is like the number of milliseconds between each animation, and somewhere here is a frames per second. So I presume I have to just figure out how these line up with each other, or what makes sense in terms of what we're able to achieve, and then also the number of iterations in there, because we're creating this chart over a certain length here for I in range. So we're doing that too, and that's basically it. So I'll leave it at that, and that's animated charts in Python using matplotlib.